Hello and welcome back to my channel. In this project, we are going to predict the price for real estate in Tokyo, the capital of Japan. So the steps that I'm going to run in this project begins from pre-process and clean data in Python. After that, we run exploratory data analysis and some descriptive statistics. Then we see the correlation between variables and we can see what type of relationship they have. And finally, just for predicting the price for real estate house, we create and run a regression machine learning supervised. And finally, for predicting the price for a house, we create a regression supervised machine learning to build a model for future house price prediction. So let's go to data documentation. In data documentation, we can see we have 4 different steps. When we work on a pre-processed data, at the first we look at the data and its dimension. Then we remove unnecessary columns because in dataset there are some variables and columns that we don't use them. Then we change the column names because those data sets come from some databases or data warehouses and you may need to change the columns names. After that, we handle missing value, duplicate value. And then we should treat with numerical variables and categorical variables in 2 different ways. In exploratory data analysis, we want to use Sweetviz package, and then we run qualitative variables, and after that we run statistical techniques on quantitative variables. In the next, we see the maximum and the minimum value for each variables, and after that we handle the outlier. Why we use outlier? Because if we didn't deal with the outlier in this project, the final regression model cannot be useful. Unless if we didn't want to use machine learning model, we didn't need to handle the outlier. Like to other videos in my channel, we run just statistical techniques, but in this video we need it. In a correlation analysis, we run Pearson correlation and ANOVA test, like to other correlation analysis, and finally we run supervised machine learning modeling. We declare the features that we need, we set up the regressor, we train the model, construct and train the model. After that, we tune and hyperparametering to have a tuned and better model. In the next, we analyze the model on a train and test dataset to compare the accuracy of train and test to see whether we have overfit or underfit. And in the next, we finalize the model, and after that, we save the model and we can finish the project. The project goal, as I mentioned, we want to predict, the final goal is to predict the price for accommodation in the Tokyo of Japan. But for doing this, we have to pre-process data, exploratory data analysis, correlation analysis, and finally creating a regression model. The language, library, and tools that I use. The language that I use, the Python. And specifically, I use the pandas and numpy library because I'm working in a tabular format. I use Pickle because I separate each notebooks, each Jupyter notebooks for each section. So I use Pickle to import and export the notebooks to each other. I use Sweetviz for statistical analysis, and as well as I use Seaborn and Matplotlib for data visualization during the analysis. I use stat model for statistical analysis as well, and I use PyCarrot and scikit-learn for machine learning modeling. And the application I use just Microsoft Excel because my file is in CSV file. What about the data? The data is very, very big data, and it is just about an accommodation in a Tokyo, there are some variables. For example, the type of a house. The house might be the residential land or agriculture or pre-owned condominium or forest land. The region, you can see the region, the municipality code, it is the code of the province in Japan. The district name or the zone in each part of city of Tokyo. The time to nearest station, it can be a factor for pricing a house. The closer house to a station, they may have the different price for a house, specifically for a big city like Tokyo. It is a minimum time to nearest station, maximum time to nearest station. The trade price or the price the house, all prices are in a yen, formal currency for the Japan. The floor plan, the plan or design plan for a floor, the area or the square feet of the house, the land shape. For example, each land may have different shape. For example, semi-rectangular, semi-trapezoidal, or other type of shape. About the front edge of a house, we have different, and we have all different variables, as well as that we have the structure. For example, if a house has a SRC, means this house's structure is a steel frame reinforced concrete. So there are different structure. It is the direction of a house. For example, it is southwest, it is toward to northwest, or so on. And you can see the data documentation to be more familiar with data. So let's see the data in Excel. It is the data in Excel. You can see all variables here, and we have different records. Let's see. We have 20,000 records for all houses in different sections and zones in Tokyo. And our goal is predicting the price for the houses. So I'm going to go to Jupyter Notebook and begin the project. So the first step is going to data pre-processing, and we want to run this data pre-processing in a Jupyter Notebook. Let's go to Jupyter Notebook. I use the pandas and NumPy, and I import the data. Let's see, look at the data. It is the dimension of the data. We have 20,000 records, and overall we have 35 columns or variables. In the next, we just remove some unneeded column, because there are some columns in a data frame and we don't need that. For example, we don't need this column. It is just because I didn't need that for my project, and you may need it, and it is up to you to choose one of them. But you should consider this point that when you want to drop the columns or variables, you should keep it in your mind that whether those variables that you are dropping can bring impact on your model or not. Sounds to me these variables cannot bring any impact, because, for example, the mean time or max time can be considered as a time to here we have the time to nearest station, as well as we have the minimum and maximum. So we don't need the min and max, and just time to nearest station can be useful. So it is a data set after dropping. In the next, I change the column name. For example, these sort of names are my favorite, and I change the column name to like this. And after that, I'm going to handle the missing values. I run a function for iterating to all columns, and we can see there are some percentage for null values. For imputing the null values, I have two different approaches, for categorical variables and for numerical variables. If I have a null value for categorical variable less than 5%, I drop them. If the percentage was 5 to 30, I impute them with mode because it is categorical, and if it is more than 30%, I create a new label as other. I don't want to drop them. I created a new label and I associated them with that new label. But for numerical variables, if the percentage of null value is between 0 to 30, I impute them with mean and mode. It depends on a distribution shape. And if they are more than 30%, I drop them. However, it isn't. This action, it is not a good idea. And in that case, the best scenario is that you must consult with some expert domains. But just because this is a project, this is a sample project, I didn't have any access to expert domains, so I prefer to drop the null values. But as I mentioned, in a real case, in this scenario, we cannot drop the null values because we may have come across drop so many different records, and it is good to consult with expert domains instead of dropping the null value. So we begin with categorical variables, and first I impute renovation, floor plan, and use. Why I impute? Because their percentage is 5% to 30. The renovation, floor plan, and use. Renovation, it is this number, use, and floor plan. All these percentage are between 5 to 30, so I impute them. And I impute them with mode just because they are categorical variables. And you can see they are the mode, and in this case, I impute fill NA or a fill null value with the mode. The mode of renovation is not yet. The mode of the use is the house. The useness of the land is just for house. And the mode of floor plan is this type of plan and design. And after that, for land shape and direction, just because they are more than 30%, the direction, this number, and the land shape, just because they are more than 30%, I create a new label as other land shape and other direction, and I associated them with a new label. And finally, I drop the structure. Why I drop the structure? Because the structure null value is less than 5% here. So far I could handle the categorical variables, but what about the numerical variables? For the near station and year, I should impute them because their percentage is between 0 and 30. It is near station, and what was the other one? It is the year. The year is which is the year? Yeah, building year. It is here, and I impute them. So for imputing them, first of all, I should see the uniqueness. So the uniqueness for the near station is this, and the near station is this. Why I did that? Because I just make sure the near station is showing the number, but it is real, the data type is a number or not. Here we can see for the building year, yes, it is number, but the near station, it is a number because it contains some string, just because the data type is object. So I was wondering to do that, and I see there are some variables and there are some values in the near station that didn't show the number. And for handling this condition, I use this method for coerce. It means I ignore this type of variables. You can see we have 10, 8, 9, 12, 10, 8, 9, 12, and after that I drop it and I have 30. I drop it and I have 30. with this action, I do this and I drop this sort of values. And then I have both of them converted to float. Nearest station is float and building year is float, and they are ready to impute with mean or median. But which of them, it depends on a distribution. I run this function to see whether the nearest station is distributed to the right skewed or left skewed. I can see it is left skewed, so I use the median for imputing. So I fill NA or fill null value with median for nearest station. The median nearest station is here. The median for nearest station, the data frame, and the median method in pandas. And I run the same process for building year, and I see the mean is imputing because it is right skewed, and fill NA for mean of building here, just for the imputing null values, and I drop the front edge. Why I drop front edge? Because the null value of front edge is this, and as I mentioned before, it is a good idea, but however in this project we didn't have other choices. And finally, if I run the null checker, we can see fortunately there is no null value. Now we can handle the duplicate rows. I run the if-else condition to see whether we have a duplicate rows or not, and we can see there are some duplicate rows, and I show them. For example, these two indexes are completely the same, and I just want to keep one of them. And there are some other duplicate rows. With this action, with this method, I just keep the first one. For example, for these two duplicate, I remove this one and I just keep this one. And you can see the dimension of a data frame is this after duplicating, handling the duplicate variables. And after that, if I check the duplicate, we can see there is no duplicate rows. And then I'm going to handle number variables. They are just number variables in my data frame, and I check whether they are number or just they are showing number. Unfortunately, we can see there is no any irregularities about them, and it means they are showing number and their data type is as well number, and everything is okay about them. And just for making sure if there are any other string values or other data that considered as a number, and we can see just because we could have a summation for each variable, so it means all values are number. So what about the categorical variables? I declare the categorical variables or string variables, and I can see the uniqueness. For example, for type, we just have this label. For a municipality, we just have Shiyoda ward, the Cho ward, Minato, and some other zones and areas in Tokyo. And they are the frequency table. You can see the most houses are in this area. The floor plan, we can see we just have one type of design for floor plan. About the land shape, we just have different land shape. About the structure, there are some structures here. So for a structure, we can see here, for example, we just have SRC and RC. They are different. However, we have SRC and RC here, or we have RC and W here. So for this case, I just use the lambda function and I split these type of values, and I remove the second one and I just keep the first one. For doing this, they are just my unique structure. And about the direction, we just have northwest, southwest, south, and so on, and this is the frequency table. And about the useness, we have a lot of different uses, because for example we have housing complex factory, it is just a label, or we have housing complex workshop warehouse. You know, just because an accommodation can be used for several reasons, and all of them are written in a database, but we just want to keep the first one. So I again use the lambdas and I take the split method and just keep the first one. And it is the labels for the useness, and they are the unique, all of them. About the renovation, we just have one label, not yet, means that house has not been renovated so far. All this process were about data pre-processing and data cleaning, and you can see all the steps in a data documentation and walk through to see what I did in this section. For exploratory data analysis, first of all, I import some important packages. For example, NumPy, Pandas, Pickle, Seaborn, and Matplotlib. We can see that's the dataset after pre-processing. And then I run Sweetviz packages and I export a statistical analysis. Let's see the export for Sweetviz packages. It's the report that is extracted and generated with Sweetviz packages, and they are different analysis for the variables, but I'm not going to talk about an analysis them in this preview. I'm going to go to data documentation and talk about them on there. So we can go to qualitative variables. Yes, here. About the qualitative variables, the first of all is municipality. We can see this area, Shinjuku and Minato, have the most houses in there, and it means in this dataset we can witness so many houses are located in these two areas. About the land shape, it means the nearly 37% of houses or lands are in a semi-rectangle shape, just because this sort of shape is very appropriate for making a house. About the use, we can see just because this data is for a real estate, it makes sense that the most of the useness just for a house, and after that the office and housing complex are in the next useness for the users. About the direction, the northwest and the southwest are the most popular, just because in the northwest and southwest of Tokyo the location was very perfect than other direction for the houses. And it is about the qualitative, and we can go to the quantitative variables. For quantitative, I prefer go to the Jupyter notebook here. First of all, I create a function to see the distribution shape. I create this, and after that I run this function for area. We can see this is the distribution shape for area, and we have a lot of outlier here. About the frontage, we can see its shape, it is the right skewed as well. However, the condition for nearest station is okay, and it is a right skewed, but it can be considered much better than this. And the building here, this is this shape, it is not normal, it is binomial, however. And about the price, we have a lot of big outlier. It is just the shape of a data, numeric data. Let's see, for example, some statistical analysis. About the area, we can see the average area is 170 square feet. About the median, we can interpret that the half of the houses have an area less than 105 square feet. And about the range means the differences between the maximum square feet and the minimum square feet is 1970, and it means the minimum house is just 30 square feet and the maximum house is 2000 square feet. and it means there is a big difference between the minimum square feet or the minimum area and the maximum area. 25% of house, because of the quartile 1, 25% of house have an area less or equal than 65 square feet. However, the 75% of house have a square feet more or equal than 190 square feet. You can see the 75% of house have this square feet, however the maximum is this, and it is just because we have an outlier in this data set. And you can have the same interpretation for other variables. You can read all of them in a data documentation. In the next, we can see what is the minimum value and what is the maximum value for each variable. For example, about the area, we can see the minimum area here is just for this house. It is just 30 square feet, and they are very, very small house. And about the maximum area, we can see they are 2,000 and they are very, very big house. About the frontage, the minimum frontage is where is the frontage? Is 1 meter. It is very ridiculous for a house in 1 meter frontage. And about the maximum, we have the 50 meters, and they are very they look like a palace maybe. And about the nearest station, the closest house to nearest station is this, even they are less than 1 minute to nearest station, and they are located in a Chao. And about the maximum, it is 16 minutes in the Minato, and this house is the farthest house from the nearest station. About the building year, the oldest house, it is this house. They come back to 1945, and the newest house is in 2020. It is the newest house, and it is the information of this house and the price. You can see, for example, here it is a very old house, this price, but it is very new house, this price. Maybe there are some other factors, and in machine learning and regression, we can analyze them for predicting the price for house. And about the price, the cheapest house is this yen, and it is the outlier that we talked about it, and it is the most expensive house, and it comes back to this year, and the area is this, and the frontage is this. So no wonder this house is very expensive. Let's talk about the outlier. For dealing with outlier, I run feature engineering. I mean, the most important factor for price in a house is the relationship between the price and area. So I create a new variable as a price per area, and I divide price by area. And I'm going to see its distribution, and the distribution is something like this. It is completely based on the price. So I'm going to handle outlier based on this feature. So just because this feature is not the normal distribution, I cannot use the z-score for imputing the outlier. Instead of that, I use the MAD technique, or median absolute deviation, for dealing with outlier. I searched on the internet, and I thought the median price per square in Tokyo is this price. So for doing this, I create sequence sections, and I'm going to analyze all data here based on this median number. In the first, I create a new empty column, and after that I create a for loop to differences between each value in a price here. Where is the price here? The differences between the median price here with this price, And after that, I get the absolute. Then for the new column, I'm going to find the median. And after that, I create a threshold. And I say, if any value is more than 3 times of this variable, the median for a new column, I can call them as an outlier. Otherwise, they are the number and they are not outlier. So I run it, and after that we can see the distribution shape from this is converted to this. So it means we could impute the outlier, and it is very, very exact techniques for imputing the outlier. But I should say again, for this imputing, I use the MAD or median technique. It is completely based on the context of the data and the project. Maybe you need to use other technique for other variables in other different data or different project. So, and it is all about exploratory data analysis, and we can ready to go to correlation analysis. In a correlation analysis, first I import the same data, and we can see the final dataset. This dataset is after imputing outlier. And for correlation, I want to see, just because the price is my target in this project, I'm going to see the relationship between the numerical variables with price for Pearson and categorical variables with price in ANOVA test. For Pearson correlation, I can see the relationship between each variable. For example, there is a positive and a strong relationship between area and the price. It makes sense. All around the world, the area is very, very important for predicting the house price. About the front edge, we can see, however, the near station has nothing to do with have a higher price. It means if I have a house that is very close to a near station, it doesn't mean that the price of my house should be more. And about the building year, there is no relationship, but however it is negative. It means in Tokyo of Japan, even oldest house may have a higher prices. I think just because the oldest house in the Tokyo are much larger than the new house, and just because the area has the positive relationship with price, it is the older house have the higher price. It is just my idea. However, for doing this, we should much more analysis that it is out of scope of this project. And we can see the correlation analysis. We can see for the heat map plot, for example, the price with area has the higher quality, and it is more than 91%. In the next, we can see the front edge, and even the nearest station and building year has the negative relationship. And what about the ANOVA test? For ANOVA test, we are going to see the correlation between the categorical variables and the price. We can see, based on the hypothesis test, we have the p-value. Just because the number of p-value is less than 0.05, so it means all categorical variables are very important for predicting the house, and we can reject the null hypothesis. So we accept the alternate, and we can see these variables should be used for predicting the house. And let's see which category or which label in those categorical variables are much important. For example, in municipality, if the house is located in Minato, can have higher prices compared to other places in Tokyo. About the land shape, if we have a land shape in Tokyo that has irregular shape, we may have more price for other land shape. And about the structure, the SRC can cause to have more price for a house. And about the direction, if I have a house in a north face, I would pay more money for buying the house. And about the use, and it means the other use for compared to warehouse, the parking, office, and housing complex, can cause to pay much more money compared to other uses. And it is the correlation analysis, and we can go to regression section for building a model. For a regression model, I first import some basic libraries, and after that I again import the final dataset, and I'm going to use the PyCaret. I install the PyCaret in my Google Colab, and after that I declare my feature. The numerical feature is these features. The categorical features is these features. However, I didn't have any ordinal features and date feature. I set up the regressor from PyCaret. I import the regression, and I set up the regression model. The model selection, my data is data frame, the target is the price. The train size, I got train size in 75% of data should be train size, and 25% should be in the hold set, which is the test side. For cross-validation, I'm going to have 10-fold cross-validation for training the model to handle the overfitting, and the session ID is 42. I set session ID to don't have shuffle or the random data. And the numeric features is these features that we declare, the categorical features here, and there is no any feature that I'm going to ignore them, and I want to use all of them. I run this code, and you can see the data set for the train is this, and the data set for testing set is in the dimension. So for hot encoding, for creating dummy variables, I selected the dummy variables for hot encoding, the categorical variables, and the fold is 10 for cross validation. And after that, I compare all possible regression model for this project. We can see the gradient booster regression, or GBR, had the best RMSE and the best R-squared. The RMSE, the best RMSE is the smallest one, and the best R-squared is the highest one. And you can see this model is the best compared to other model. So just because this model is the best, I create a regression based on the gradient booster regressor, and then I'm going to hyperparameter tuning to see whether I can increase the accuracy or decrease the RMSE. So as I mentioned, the best RMSE is the least one, and the best R-squared is the highest one. So I hyperparameter tuning, and we can see the R-squared in after tuning or after hyperparameter tuning is less than the original. So it means I roll back the model, and I want to use this model instead of the tuning model, because the result for tuning model was worse than the original one. So I'm going to analyze the model on a train and test based on the model. So we can see here there is the error prediction shape. Just because the most of the data is close to the zero, it means the prediction of the model is very acceptable. However, there are some outlier, and there are some error or residual here. They can be normal, but the majority of data is close together, and they are close to zero, and it means the accuracy of model is very acceptable, and we don't have any overfit or underfit. And let's see the learning curve. The learning curve is a very good plot for see whether we have an overfit or underfit on a model. You can see the cross-validation or score, or the training score, is near to this number, 85%. You can see here we have this accuracy, and it is plot here near to 85, and it is the learning curve. Just because the accuracy for training is increasing and the learning curve is decreasing, it means the gap between these two lines is decreasing, and it means our model is learning step by step during any cross validation, and it means we don't have any overfit and underfit on a model. And about the feature importance, we can see the area, as we see on a correlation analysis, has the most impact on a model. So if we didn't have any plot like this, or if we have other variables except area, we could see the model have some error. Just because in a real estate industry, all of us know, in a real estate industry, the most important factor is area. And for example, if we see the direction north was the feature, the most important features, we could see there is something wrong about the model. But but in this plot, we can see the model is working very well, because the most important feature is area, and after that we can see the front edge. It is just because we confirm is model working based on a real conditions or not. Unfortunately, for our model is working based on the real condition. And finally, I'm going to see the model on a test dataset, because all these analysis based on the performance of the model on a train set, and we can see the accuracy for a model on a train is this number. Let's go to data documentation. In a data documentation in a finalized model, you can see the train accuracy was 0.84, but for train is 0.81. It is exactly correct, because if the accuracy for test was higher than train, it meant we have overfit. And if we had the big difference between the train and test, we have underfit. Fortunately, the differences between this number and this number is very small, and we can see the model has neither overfit and underfit, and it is just working completely correct. And so it is the just prediction on a model. So now we have the model, and we see the train accuracy and test accuracy, and everything is okay. So now we can try whether we could improve this model or not. So I finalized the model, and it is all pipeline for the model. You can see all steps and all things that the model should be worked. And I finalize the model, and then I predict again. But in this case, not only on a test data set, I run it for all data sets. And we can see we could increase the accuracy of the model to this number. And we could increase the accuracy from this number, from these two numbers, to this number. This is just because in this case, I trained the model on a train set, and after that I test it on a test set. But in this case, I create a model from the scratch as a pipeline, and I run it for all data sets, and we can see the accuracy was completely acceptable, and it is very high accuracy, and we can trust this model because we tested this model, and this model has no overfit and underfit, and we can trust this model. So if we finalize the model, we can save it, and we can hand over this model to software developers, to or other engineers in a company to deploy it and use it for other predictions for managers. As a data analyst or as a data scientist, your work ends here, and after that you should export the model and hand over it to computer engineers or software developers to deploy it on server or other features in a company. So in this project, we run a machine learning model from the scratch, from data pre-processing, from exploratory data analysis, correlation analysis, and creating a supervised learning model. And it is a very interesting project, sounds to me. So I hope you enjoyed this video, and thanks for your watching.